Hello, friends. Welcome everyone to the 16 artifacts to capture when there is a production problem in the Kubernetes environment. I would like to first of all thank each and every one of you for taking your valuable time to attend this talk. Okay, so friends, when a production problem happens, we don't know whether it is caused because of the threads getting stuck, or whether it's caused because of a memory leak, or whether it is caused because of a network outage, or because of lack of storage, or because of some kernel issues, or some issues in the container orchestration. Right? We don't know where it happens. So whenever any production problem happens, it's always one of the best practice to capture the 360-degree data. So what is the 360-degree data that we want to capture? So this is that list, what we have come up with, and we have found it very practical use case of having this data to troubleshoot any sort of production-related performance problems, right? So this is that 16 artifacts. So in this talk, we are going to go into the detail of these 16 artifacts and how they can be helpful for troubleshooting the production problems in the containerized Kubernetes environment, right? We will talk about these 16 artifacts in a minute, but how we are going to capture these 16 artifacts, right? So we can't execute individual commands to capture these artifacts. So what here I'm going to be sharing with you is, here there is an open source script, which is called as a Y-Crash. It's an open source script. It's published in GitHub. So when you trigger this script, so this script captures you a 360-degree data that all those 16 artifacts, which we saw in the previous slide, right? And how to trigger this script in your Kubernetes environment, right? So there's 3 options in which you can trigger this script. So the first option is this script can run as a separate sidecar, right, along with your other containers. This is one option in which the script can be installed. And see, this is, at the end of the day, it's a very simple Golang script, and it's available as an exe format or as a shell script for you. So you can deploy this in a separate sidecar. This is one option. The second option is you can have this script installed on the same container where your target application is running. So this is a second option. The third option is you can also have this script installed in the host, right? And the host, instead of within the container, sidecar can also be deployed on the host, right? So you can give this. And then the another one more option that maybe what I want to highlight is, see, if your Kubernetes, your pod, a container is recycled because of instability, then there is a concept called pre-stop hook. So to this pre-stop hook, also you can specify this Y-Crash script, this YC script. When you specify the script before your container gets recycled, the script gets triggered, and it's going to capture this 360-degree data for you. Okay. One more point that I want to highlight here is, okay, so now we have captured all these 16 artifacts. Okay, so these 16 artifacts can be configured to be returned. You have few choices how we are going to get hold of this artifacts, how we are going to get hold of the 16 artifacts. So one option is you can to this script, you can configure an endpoint URL, right? So when you configure this endpoint URL, all these 16 artifacts is going to be bundled as a zip file, and then it's going to be transmitted to that endpoint URL. It can do a curl post, or it can also create a bundle file and then write it to any disk location or any storage location you specify, so that you can have this data captured for you, right? Okay. Having said that, let's get into each and every artifact, how and why it will be useful, right? See, the first and the foremost artifact, what we are talking about here is the garbage collection log file, the GC log file, right? See, a lot of people are under the impression the garbage collection log is only meant for troubleshooting, for bringing down your GC pause times, right? So that is one primary use case why you want to use GC log. But GC log, the garbage collection log, is very vital to even to predict the outages. So, like, by looking at a GC log, you would be able to say, like, several minutes ahead whether your application is going to have a memory problem or not, right? So to do that, let me show you few GC log patterns, right? Okay. Look at this. So this is a pattern of a very healthy application. This is a GC log analysis pattern of a very healthy application. You can see the request comes, the memory keeps building up, and a full garbage collection event runs, the memory drops all the way to the bottom. And the request comes, memory keeps building up, a full garbage collection event runs, and the memory drops all the way to the bottom. Right? I see this beautiful sawtooth pattern. Right? Now, look at this GC garbage collection log pattern. Look what's happening. The request is coming, the memory is building up, a full garbage collection event runs. The memory is dropping here at right now it's dropping. If you see, it is at 22 GB, right? As time progresses, you see the memory builds up, but a full garbage collection event towards this last thing, if you see this last full garbage collection event, if you see the memory, it has dropped not to this 22 GB mark, it has dropped only to this 32 GB mark, right? And if I draw a slope for this graph, which is the slope is, we can derive it by y is equal to mx plus p, right? It's an high school mathematical formula, but people today, they're calling it as a machine learning, but let's not get there. But let's say using this slope, if you see this slope, this graph slope is going at a kind of 18 degrees. So if this application is going to progress like in this manner, it's confirmed that it's going to reach its memory limit, and then it will have a memory problem eventually, right? So this is what, so if you, okay, now look at this one. Look at this garbage collection log pattern. You see the memory build up, when the garbage collection event ran, the memory is dropping to the bottom, right? You can see this happening. But after a point in time, you can see the full garbage collection event keeps on running infinitely, right? You can see it keep on running running again and again and again, but the memory is not getting reclaimed. So when this kind of a pattern happens, your CPU will be skyrocketing. Your CPU will be at a 99 or 100%, right? And any request that comes to this application, it's not going to get back any response because garbage collection is running repeatedly again and again and again. But friends, all our monitoring, right, today, they come and report the problem, or you get out of memory error only when you reach this maximum limit. You see where my mouse is hovering, right here only you're going to get out of memory error. But way before, several minutes before, here there is an indication that a repeated garbage collection has started to run. You can see the repeated garbage collection has started to run way before. So if I can detect this one, oh, the garbage collection event is running frequently, that means there's a problem started to brew in the application. Then you can take any corrective actions, like maybe you can decommission your JVM from the load balancer, recycle it, and then move forward, so that you don't want to wait. You don't want to be reactive. Rather than we can be proactive and detect the problems much earlier in the game using this kind of a garbage collection log analysis. Okay. So now progressing. Here I'm sharing with you some of the freely available garbage collection log analysis tool. You are welcome to use whichever the tool you want. So they can do the analysis and they can tell you, and there is even REST APIs available so that you can do a real-time monitoring of your garbage collection behavior, right? In the interest of time, I'm not going to be going into each and every tool here. Okay. So now progressing along, the next artifact that what you want to capture when there's a production problem is a thread dump. See, what is a thread dump? See, this is how a typical thread dump looks like. So thread dump is going to show all the threads that are running within your application. Say our applications may have like a few hundred threads, and it will show what lines of code they are executing, and if they're holding on to any locks, it's going to tell what are the locks it's holding on and what state it is. So this is how a thread dump looks like, right? See, whenever you have problems like your application is becoming unresponsive, or whether it's having a deadlock, or whether if the threads is for some reason you're not getting any response from the backend system of records, any problem that will be visible in the threads. Most of the problems will be reflected in the threads, right? Say what happened, say if one of your backend system of record is not responding, then what will happen, multiple of your threads is going to go and stuck waiting for the backend call. You'll see a lot of things waiting there. And if your application has gone unresponsive, then your threads maybe have gone into blocked state. If you capture a thread dump, you'll be able to visualize it. So thread dump is extremely powerful to analyze most of the performance related problems in the production environment. So when you run this YC script, what it's going to do is it's going to capture 3 snapshots of thread dumps for you in a gap of 10 seconds, and then it's going to be bundled up for you for analysis, right? So now let's quickly, here are some of the freely available the thread dump analysis tools, which you can look at it for visualization or for analysis purpose. So let me quickly show you one of the report, right? I uploaded one thread dump in one of the thread dump analysis tool called as a fast thread, which you are seeing now. So it has very interesting metrics like what states the threads are and how they are looking like. And here is what we call this as there's a transitive graph, right? It is showing, okay, these are all the threads which are being blocked by this particular thread. So it shows at the kind of the simple English, it's saying like 646 threads are being blocked by this particular call, by this particular API call. Like these are those 646 threads, right? These are the 646 threads. And this is the culprit thread which has acquired the lock and it hasn't released. So if you want to go see what is this thread is doing, I can click here. So when so let me click here. So now I'll get to see the stack trace of this thread, which is a culprit thread, which is making all other 646 threads to be stuck. By looking at this stack trace, one thing what is getting clear or visible is this thread can UUID call, the random UUID call, which is a part of the JDK API available. When this API call is invoked, the JDK makes a call to the operating system to generate the random numbers. At the kernel level, there is a concept called entropy. That is, to generate random numbers, the kernel uses certain noises, like the keystroke, what a user does, or the mouse movements, or the noises generated by the device drivers. It uses those randomness to generate the random numbers. Sometimes if there's a lack of entropy, at the kernel level, then the UUID generation will slow down. And so that's what is happening here. Because of that, this entire threads are getting stuck. And not only that, there is very powerful visualizations. Like here, there is this flame graph. It kind of shows the entire concentration of your thread dump file can be few kilobytes, sometimes even few megabytes. That entire thread dump can be condensed and presented to you as this flame graph. I can drill down and see what's going on. Or if you want to search for a particular framework, I can do those things. So that it's pretty easy for me to visualize and see what's going on here. Okay. So this is the second artifact that what we want to look at capturing when there is a production problem. The third artifact, what we want to look at capturing is EEP Dump. That is, the second artifact, what we looked at just now, is a thread dump, which is basically a snapshot of all your threads. The EEP Dump is basically a snapshot of your memory. Say, if your application is running into memory leak, it is having out of memory error, right? We want to capture a EEP Dump so that I'll know what are the objects which is there in memory, what is it referencing to, and why it is not, what is keeping it active, and what is preventing it from garbage collection. So I can look into those things to get to the root cause of the memory leak, right? So you want to use this script captures the EEP Dump for you, right? So here are some of the EEP Dump analysis tools which you can look at using for analyzing your EEP dumps to see what is causing the memory leak. Friends, in all these three artifacts, like whatever we have discussed here, these are captured from the JVM, from the Java virtual machine. See, the garbage collection log capturing, because and the thread dump will not add any noticeable overhead for you. And in fact, we have done research and we have published some white papers showing that it doesn't add any noticeable overhead. But on the other hand, EEP Dump is an intrusive operation. That is, EEP Dump will pause your application, and then it's going to take the snapshot of your memory and then it's going to write it to the disk. Entire time your JVM is going to be paused. So you don't want to capture an EEP Dump unless you know it is a memory leak. If you, absolutely, when you know it's a memory leak, that's when you want to go for capturing this EEP Dump, because it's an intrusive operation, right? So that's why this YC script, the YCrash script, does not capture EEP Dump by default. You need to pass an explicit flag to capture the EEP Dump. So as an alternative to that, this Y-crash script, or it captures something called as a EEP substitute. It captures the EEP substitute. So this EEP substitute has a just enough information, statistical information, like what are my classes and how much size they are occupying, what are the objects, what size they are occupying. But I wouldn't be able to see what data it contains. It's not intrusive. So it is a very lightweight alternative to EEP Dump, and it doesn't pause your application. It is non-intrusive capturing, right? So like the EEP substitute, it captures this, it gives kind of a class histogram, like what are the number of instances of object and what classes they are, I get to see, and what is my EEP sizes, I get to see this information. So this information, get it from issuing these commands, the JCMD, class histogram, system properties, EEP info, right? So this can act as some level of alternative to EEP Dump, right? So this is captured for you always. Okay. So the next artifact, what we want to look at capturing when there's a production problem is a top data, right? So what is top data? See, the top is available in most of the Linux and Unix distributions, right? So when I capture this, issue the top command, it's going to display me all the processes running on that container and how much CPU and memory that each process is taking. See, a lot of times outage can happen, not maybe because of my application. Maybe there is some other process, maybe there's some other Splunk script, there's some other cron job which is running on the container, and that is chewing up the CPU. And that is causing that can result in a CPU starvation, and that can cause an outage for my application, right? In that circumstance, capturing this top data will be very vital, right? And not only that, in the containers world, in the Kubernetes world, there is sometimes your container may not be given enough CPU cycles, and it is stolen and given to some other container which is running in the same pod. In those circumstances, there is this metric here, what is reported as a stolen CPU time, which is a very vital artifact that you want to be looking at in the Kubernetes world. So this is going to be available for us. It also reports you kind of a load average. So this is a metric which is available here in this top command, which you see as a load average, where you see my mouse is moving. So this is telling me what is the load average of my container in a 1 minute, for the last 1 minute, for the last 5 minutes, and last 15 minutes, right? So sometimes there may be a burst of traffic, a momentary traffic, maybe a surge and going down. In that case, maybe a 1 minute average may be very high. But let's say if consistently there is a very high stress, very high load on your container, then you may see this 5 minute and 15 minute average to be spiking up, right? So these information will be very vital and very helpful to troubleshoot the problems in the container world. And the next artifact, what you want to look at capturing is the PS, the process status, right? See, when I issue the process status, I'm going to see all the processes running on that container. Right? So it gives me the one beautiful thing. What it gives me is it gives me the full command line arguments in which that process has been launched, right? If you see the stop command, it only gives the initial few characters of the process, but I will not be able to see the complete arguments in which this. See here, I just see one process it's a Java process. It says it is consuming 199% CPU, but I don't know what arguments with which it has been launched or what Java process it is. But if I can see all the arguments with which it has been launched, I know, okay, oh, this means this is my middleware. Oh, it means this is some other batch Java process. So I'll get to know. So the PS, the process status command, is going to give us the complete arguments. So marrying this data, the top data, will help us to get to know what is the problem that is going, or what is the process, the complete details about the process. So this kind of marrying the process status with top will be very useful in troubleshooting what is the problem or the issues caused by the neighboring applications. Okay, okay. So this is an interesting data that what the script captures. It's called the top-h. See, friends, a lot of time in our application, the CPU spikes up. CPU spikes up to 90% or 95%, 100%. But I don't know in my process, I don't know what lines of code is causing my CPU to spike up, right? So always, but in general, always the CPU spiked up because of threads. Only the threads cause the CPU to spike up. So my application may have like hundreds of threads. In these hundreds of threads, how do I narrow down to tell, okay, these are the exact threads which is causing the CPU to spike, right? That's when this top dash H will be helpful. So top dash H, right? When you issue the top dash H minus P and give you a name of your process ID, it's going to list down all the threads which are running within that process. Say, if I say top dash H minus P and give a name of your the process ID, which is having trouble, which the script does it for you automatically. It's going to list down, okay, oh, these are all the threads running in this process. And this is how much CPU they are consuming. So how much CPU and memory they are consuming. It gets reported here. I can see, even though my application is having hundreds of threads, like these are the 3 threads, 69.3%. This thread 31306, which is a thread which is running within my application, is consuming 69.3% of CPU. The another thread 31307, it is consuming 65.6% of thread. So like this, I will get to know per thread level detail. So once I have this, then I will narrow down what are the threads which is causing the CPU to spike. And now I know, since the script is, since we are capturing a thread dump, I will know what, with the thread dump, I'll know what the lines of code these threads are executing. When I take this data and marry this data with the thread dump, I will get to see the root exact line of code, which is causing the CPU to spike, right? So now the next artifact, what we want to capture when there is a production problem is a disk usage, right? See, sometimes due to lack of disk usage, especially in the maybe your application is logging and there's not enough log in the container, or in the, if you have pointed it to writing the log on the host, maybe there's not sufficient disk space on the host, then we will run out of the, if you cannot log, then it can cause some outages or issues in our application. So capturing disk usage will get us a visibility what's going on at the disk level, at the storage level. So this is the df minus f, right? It gives you this. See, what does this whitehash script does? Use the command, equivalent command in Windows and Linux. Based on the operating system, it issues the appropriate commands and captures the data for you. So it is actually platform agnostic. Okay, so in Linux, it issues a df minus h and gives me this data, and then it's presented. Oh, here I see, okay, everything usage is 0%, but sometimes if it's 90%, 99%, then something we have to look into and fixing it. Right? The next artifact, what you want to look at is the D message. See, sometimes what happens is our kernel may have hiccups. The kernel sometimes can kill our application. The kernel may have some network interface errors, some device driver problems. So the issuing this D message command, it gives me the kernel logs, what's happening in the kernel level. And this is very helpful. Sometimes we are seeing solve very interesting problems because of this kernel logging, right? So say, there are a few examples that I can cite, but maybe let's take a little bit time, right? So let's look at this. This was one of the issue that was posted by one friend. He was saying, look at this. He was saying that his JVM is restarting at different points on the same server, right? So what he has is, he has different JVMs, which is running on the same server, but they're getting restarted at different point in time. And they were looking into the thread dump. But when this D message was issued, which was giving a kind of the kernel log, what it pointed out was, because of lack of memory, the kernel was killing the Java process intermittently. So that was getting very evident by looking into the D message, by looking at the kernel commands, right? So that came to the kind of the visibility. Okay. So now moving along. The next data, what you want to look at analyzing when there's a production problem is maybe netstat, the network data. So I want to see, when I issue this netstat command, I'm going to see all the network connections that is established with my container. Right? These are the hosts to which it's connecting and what states they are, and it's going to present me this count. but let's say there is some slowly responding system of record, right? In that case, the number of connection counts is going to go high for that host. And then it's going to come to visibility. And sometimes because of some kernel issues, maybe if the system of record is not connections, then you may see your connection state to be in a fin wait, closed wait, starting to build up. So having this information will help you to isolate most of the network related issues. Right. The next data, what you want to look at capturing is the ping, right? It's a very vanilla thing. So from my host, I want to configure how long, what is the round trip time? Say here, I want to say the google.com, or you can configure any host to that YC script. When you do this, it's going to show me what is my round trip time. So here it says my round trip time, in this case, it has come to average as 1.74 seconds. But let's say if there are some network hiccups, then this may become like a 5 seconds or 6 seconds, right? Then that is something we want to look at investigating. Okay. So the next data, what we want to look at is the VM stat information, right? So the VM stat, it gives me kind of information of what is swap going on, what is my IO rate, what is my different CPU utilizations, whether any context switching happening. Those information is visible, right? So which is also comes helpful to isolate any container related or any infrastructure related problems is going to come to my visibility, right? Okay. So, and then the next argument, what we want, next data or that what you want to look at capturing is the kernel parameters, right? So I want to see whether, sometimes I've seen getting especially now it is in a kind of a remote environment and where we don't have any insights, right? We don't know what's going on, and it gets on the pod, the content gets recycled and comes back. We don't know what's going on. So capturing this kind of kernel information will tell me whether the configurations there are right or wrong, or whether some TTLs or whether they are over configured, right? So it comes to our visibility. So it gets easy to narrow down any system level infrastructure related issues. The next data that what we want to look at capturing is sometimes our application log will contain a wealthy of information, right? Maybe there are some exceptions going on and I want to look into that. So I want to take a snapshot of my application logs and then bundle it for my analysis. So this something the script gives you a provision to capture that, right? The next one is what we call as a kind of a metadata, right? It kind of gives the information like this process is run as whom, what version of Java, what version of OS, and some details about that the host and the container is visible for us to take and do the digest. Okay, friends. So these are the 16 artifacts, right, that we want to look at capturing when there is a production problem, right, in the containers and Kubernetes world. So we have also shown about a scripted way how to do it, right? So I'm here open to take any questions. Like you are welcome to ask any questions if they are there. Yeah. And this deck we are going to be publishing here in this blog.ycrash.io. Right. Any questions from anyone?
Look at your chat.
Okay, so you're saying no questions. So I'm here. People are welcome. If any questions you have, you're welcome to ask. If not, that's fine. Okay. So, friends, one thing that maybe I want to say, if you guys don't have, like all these 16 artifacts, you can analyze them manually also, or there's a Ycrash server, right? We do have a Ycrash server. So this server can capture all these 16 artifacts for you, and from your container world, it can transmit. So directly to the Ycrash server, and this kind of a dashboard will be presented for you. So here I can see what all the incidents that has happened here. So I can click on one of them, and then here I can see all those 16 artifacts has been analyzed and then presented to me. The GC log information, right, is available. I can see this in one dashboard, what's going on and what's going on with my threads, right? All this analysis I can get to see. And in fact, this tool has married my top dash edge data with the thread dump and presenting, okay, this lines of code is causing 15% CPU. And then what is happening with my processes, right? That this is presenting me what all the processes running on my container and how much CPU and memory it is taking on. So it gives me these kind of all the data that we captured is presented for you for analysis. So you're welcome to use this one also, right? Just presenting it. Okay. Yeah. Questions? Anything from anyone? So then I assume there are no questions. So then probably we can end this conversation, end this session. So thank you everyone, friends, for attending this call. You're always welcome to reach me in any one of these channels. Okay. So thank you, friends. Bye-bye. Thank you.